In section 12.3, we're going to talk about the area of cylinders, cones, and spheres. And I'm going to show you one of these formulas. I'm not going to show you all of the formulas. Some of these we might have developed if we were in class, but I don't think we have time to do that. Some of these are actually developed using calculus or higher level math. So I'll show you one that's within the range of things that we should be able to understand. So here's a cylinder, okay? It's a can of food. And I want to think about finding the lateral area of this can of food. Okay, so imagine that I have a cylinder that has a radius of r and a height of h. Okay, so here we go. If I'm trying to find the lateral area of this cylinder, I'm trying to find the area of the sides of the can. And when I first started thinking about this, I thought, oh man, that's really complicated because it's bent and you know, it's a weird shape. But it's really not a weird shape. Because if you imagine the metal that makes up the sides of this can, that's really the label that goes around the can. The area would just be the area of the label that goes around the can. All right? Well, think about that label. If you take that label off that can, it's a rectangle. And it's really easy to find the area of a rectangle. So the question is, you know, the height of the rectangle, of course, is going to be the same as the height of the cylinder or the height of the can. But the question is, what is the length of that? Well, I'd like you to watch me put this label on. As I put the label back on the can, I want you to think about the length of that rectangle. Okay? Hopefully you can see the length of that rectangle. It has to go around the entire can. That's the circumference of the cylinder. So if you're trying to find lateral surface area, you can really just imagine peeling the label off of the can. The height is going to be the same as the height of the cylinder, but this thing has to wrap around the cylinder. If you remember, the circumference of a circle is 2 pi r, or you could use pi times the diameter, but we'll use 2 pi r. That's that distance all the way around the can. So this length here is going to be 2 times pi times the radius, and that's going to lead us to the formula for the surface area of a cylinder. Surface area of a cylinder is just area of this rectangle. It's 2 pi r times the height. 2 pi r h is the formula for the lateral surface area of a cylinder. Pretty basic formula, okay? So that's our first formula. Now I'm going to give you 3 formulas, and you really need to know these formulas, okay? These are considered to be pretty basic formulas in mathematics, okay? So number 1, the formula for the lateral area of a cylinder is what we just showed. Lateral area of a cylinder is 2 pi r h, okay? That's the lateral area of a cylinder, all right? The lateral area of a cone, and I'll show you how this gets used in a minute. It's a pretty simple formula. The lateral area is equal to pi r L, okay? And some of you might not even remember, but I believe back in section 9.8, we used L to represent the slant height of a cone. Pi times the radius times the slant height of the cone, okay? And the final formula we're going to look at in this section is the surface area of a sphere, okay? And I'm not going to talk about lateral area. A sphere only has one surface, so we don't really talk about having sides and a base. So I'm just going to talk about the surface area of a sphere. And this can be proved using calculus. The surface area of a sphere is very, very close to the area formula. Remember, area of a circle is pi r squared. The surface area of a sphere is 4 pi r squared, okay? It's just 4 times the area of one of the circles if you sliced your sphere open, which is kind of interesting, okay? So those are the 4 big formulas that we need to know, all right? So let's run through a couple of example problems here. All right, so let's say that I had a cone that had a, sorry, not a cone, a cylinder that had a radius of 5 and a height of 8, okay? And I'd like to find the lateral surface area of that, okay? The formula is just 2 pi r h. You could toss it in the formula. If you're not somebody who remembers formulas well, you can think about peeling the label off the can. The height of the can is going to be the height of the label. This label has to wrap all the way around the can. So you'd be taking 2 pi times the radius of 5. That would give you 10 pi. 10 pi times 8 would be 80 pi. That would be the lateral area of that cylinder, okay? And of course, you could also just pop that in the formula. So 2 pi r h. Radius is 5, height is 8. You're going to get 40 times 2 is 80 pi, okay? 2 pi r h. Pretty easy formula to use. Now, if I ask you for the total surface area of the cylinder, you've got a little bit more work to do. Lateral area here is 80 pi, okay? The total surface area is going to include the top base and the bottom base. Remember that the area of a circle is pi r squared. So the radius is 5. 5 squared is 25. The area of that base would be 25 pi. We have a second circular base that also has an area of 25 pi. So you're going to add the 80 pi, and you're going to add the 25 pi, and you're going to add the other 25 pi, and that ends up being 130 pi. And again, technically should be square units for both of these for the total surface area of that cylinder, okay? That's the big idea there. All right, let's look at the cone formula. All right, so the surface area of a cone, it's a simple formula, pi times the radius times the slant height. So you just need to make sure you have both of those. Sometimes they'll give you those. Sometimes you're going to have to do a little bit of additional work. So let's say I have a cone here. I got a circle base, comes to a point at the top. Let's say that the base area is 25 pi, and let's say that they tell us that the altitude of this cone is 12, okay? If I want to find the lateral area is pi RL, pi times the radius times the slant height. Remember, the area of a circle is pi times the radius squared. So if the area of the base is 25, that means the radius would be 5, okay? Now, the slant height. This is the slant height. Altitude, slant height. That's your L value, okay? So your question here is, how am I supposed to find the length of L? They didn't give it to me. Well, if you look at the problem pretty carefully, this goes back again to some of the strategies we looked at in section 9.8. You can make a right triangle. So if you draw this radius in here, the radius length there is 5, okay? And now you should be able to use the Pythagorean theorem to find the missing side, but let's use the triple, okay? This is a 5, 12, 13 triangle, all right? And so the slant height ends up being 13. So I write down the formula, I fill in the numbers. 5 times 13 is 65, and that's getting multiplied by pi. So 65 pi would be the lateral, technically square units, would be the lateral area, okay? If they ask you to find the total surface area, of course, we'll list that the lateral area is 65 pi. If they ask you to find the total surface area, remember you need to add the area of the base. Okay, so that would be 65 pi. We'd be adding that 25 pi, and the total surface area, I believe that would end up being 90 pi square units. Okay, so that's how the surface area formula for a cone will work. And finally, a sphere. Okay, so a sphere, you basically just drop everything in. So if we have a sphere here, we've got maybe something goes around like this. Sometimes they'll kind of give it some depth, showing if you slice it and you open it up, you can see that circle across there. It's called a cross section. If you slice something open and you look at it. The largest circle that goes around the outside here, by the way, is called a great circle. It's the biggest circle, the greatest circle. Let's say that the radius here is 5. To find the surface area, how many square units would be on the outside of that sphere? If you were making a basketball, how much rubber or leather or whatever you had to use to make the outside? It's just going to be 4 times pi times the radius squared, all right? 5 squared is 25 times 4 is 100 pi, okay? That would be the surface area. 100 pi square units would be the surface area of that sphere, all right? Pretty easy formula, just kind of a plug and chug kind of thing. I did want to mention one other thing. There's also something known as a hemisphere. A hemisphere is half of a sphere, okay? And that might look something like this, and same kind of thing. We can put a radius of 5 in there. Be careful if you're asked to find the surface area of a hemisphere, okay? Yes, you can find the surface area. It's going to be 4 pi times 5 squared, and it's going to be 100 pi. And so people say, oh, it's a hemisphere, it's half. I'm just going to chop it in half. Well, sort of, okay? If you divide that by 2, you're going to get 50 pi, okay? 50 pi is really just the area of the curved part, okay? By slicing this thing in half, I've actually created a new surface. We now have a base down here, okay? And that base circle has an area of 25 pi. So you're going to have to add the area of the base, okay, 25 pi, and we get 75 pi square units. So be careful. They ask you for the surface area of a hemisphere. If you think about it, you're creating a new surface where you slice it. So you've got the half curved part and you have that circle base, okay? And by the way, some of you might notice this is 3 pi r squared, which actually would work to find the surface area of the hemisphere. So I'm not sure if that's a formula in the book, but sometimes people do kind of pick up on that. So hopefully that's a pretty good overview of what's happening in 12.3. And now I'll leave you guys to go ahead and work through those example problems.